Hi, my classes. I had assigned you two mixed review assignments. I'm going to take a couple minutes to go through the first one. I'll make a second video to go through the ones 522 to 527. This is not going to be the best video you ever did see because I'm clearly sick. Okay, so for 498, data from a study of a vitamin supplement that claims to shorten the length of a common cold is shown below. Okay, the irony in this problem. So the first thing I did was I took this data and I put it into Desmos. My first my first row was my X's and the second one was my Y's. There was a button up here in the top left I pressed up here to get the line of best fit to show, and that's my linear regression. Okay, you can see it down here. Okay, this is where I'm going to get my first couple of answers. So it says, determine the LSRL of this data, which we did. Create a scatter plot of this. So maybe draw a little example of what that looks like on your paper. This was done on Desmos. And then draw the LSRL. So you can write on your paper that you did it on Desmos, but just make sure that you know how we entered this and how we got the LSRL to pop up. Okay, so then the next question says, is a linear model appropriate? So before showing the line of best fit, you have to be able to approximate if that looks like a straight line pattern or a curved pattern. I'd say this follows the pattern of a straight line. So yes, a linear pattern is okay. Calculate R. R squared we're not going to focus on. On future tests, I will ask you about R though. Okay, so calculate R and interpret it in context. Our R value is down here, negative 0.9. So the negative tells us that it's a negative correlation, which we can see from the negative slope. And then 0.9 describes how clustered our data is. So here was what we went over in class. We can see the closer you are to -1 or +1, the closer your dots are to your LSRL. The closer to the center you are, the more scattered. So when it says interpret the R, since R value was 0.9, oh, I'm sorry, wrong tab, negative 0.9, that's really close to -1. So you'd say it's a really strong correlation. Describe the association. We should talk about form. The form is linear. Direction is, it is negative. You can see that from the slope. The slope is negative 1.5. This is a negative sloping line. And the strength is strong because the R value is close to -1. I don't see any outliers in our graph. At this point, you should pause the video. Make sure you've answered all of these questions on paper. For 499, you have to find other variables that could be actual causes of the issue. Like, for instance, in class when we talked about this, we said that in the summer, or we said ice cream sales increase at the same time drowning increase. But then we talked about in both cases it's hot outside. So it's not really that the ice cream is causing people to drown. It's just that both increase in the summer. That's called a lurking variable. So for A, it says teens who own their own cars are more likely to crash. So a lurking variable for this one could be like if a teen has a car available, they're more likely to be able to drive right away. They don't have to wait to share with their sibling or their parent. So that extra time on the road just increases the probability that something bad could happen. And B, bottled water is linked to healthier babies. So this doesn't necessarily mean that the bottled water is what's making the babies healthier. But if you have the type of income where you're giving bottled water to your babies, you're probably spending extra money on other things. I don't know, vitamins, nutritional food, things like that. Okay, make sure you pause and write down your answers for 499. For problem 100, we have all these exponent rules we learned. Let me see if I have them open. Okay, I don't have the tab open, but I can write them down. So when we divide like bases, so we could expand this the long way and write out however many x's are in the numerator and however many x's are in the denominator, then simplify by canceling. But with really big numbers, that would take a lot of time. So we did learn a shortcut in class that tells us just to subtract our exponents. So in this first case for 100A, 150 over 50, although 150 divided by 50 is 3, in this case we're not actually dividing our exponents. We should be subtracting our exponents. So the answer is incorrect. It should be 150 minus 50, which is x to the 100th. In the next example, for B, if you have like bases being multiplied, you could write this out in expanded form and write A amount of x's and then B amount of x's, all connected by multiplication. But when you combine them, it's just the same as adding however many you had from each case. So in this case, y to the 20th times y to the 41st, you would add those together and get y to the 61st. So checking our answers, B is correct. Okay, and then the last rule for C that we see here is if you have multiple things being raised, oh, I guess we have two rules, being raised to a power, each piece will get raised to that power. And we also have another rule saying if you have some set of exponents, you will just end up multiplying those. Okay, because this would be like having a number of sets of B items. Okay, so that's like multiplying. So when we expand this first problem, let's see, let me make some room. 2m squared n to the 15th all to the third. That would be like writing this out 3 times, but I'm not going to write it out 3 times. I'm just going to separate it into kind of like piles. We're going to have 2 sets of 3. 3 sets of 2. We're going to have 3 sets of m squared, and we're also going to have 3 sets of n to the 15th. So 2 to the third is 2 times 2 times 2, which is 8. If you have 3 sets of m squared, you really have 6 m's. And then if you have 3 sets of 15 n's, that's 45 n's. The problem with the answer they provided is they forgot to apply that exponent to the coefficient in front. Okay, with 4101, you could grab a graph and do it that way, like a more concrete method, but 12 isn't usually on the graphs I provide, and sometimes you won't always have graph paper with you, so I'm going to show you an algebraic method. So we always are using the formula y equals mx plus b in class. With the information provided in 101, they gave us m, so that's the slope, is negative 4/3. And they also gave us a point 12, comma, negative 4. Now, ordered pairs are given as x, then y. So when I plug this into the formula, don't be fooled. A lot of kids will accidentally put the y is 12 because it came first. But remember, ordered pairs are x, then y. So the y is negative 4. The x is 12. And what we're trying to find out is what is the y-intercept, the b value. So when we're multiplying whole numbers times fractions, we multiply by the top and divide by the bottom. You could do that in either order. I like to divide first so my numbers are smaller. So 12 divided by 3 is 4 times negative 4 is negative 16. So let's just say you did it the other way. If you multiplied first, 12 times negative 4 is negative 48. Then when you divide by 3, you get negative 16 either way. So to get b by itself, we're going to add 16 to both sides. If I owe you $4 and I pay you 16, I've overpaid by $12. So now I have enough to plug into y equals mx plus b. We know the m was given to us. That was negative 4/3. And now the b we know is 12. Pause the video, make sure you have some work shown. Okay, in question 4102, you're looking for an equation that goes to no solution. So I know something is no solution when all the x's cancel out and I'm left with something false, like 0 equals 2 or negative 4 equals 6, something where it's unbalanced. Okay, so if I'm going to work backwards, let me just pick an example. Let me say 1 equals 2. That would be no solution because it's false. Okay, so how can I make this balanced, but I want to use x's? I'm going to just add some amount of x's on each side, some balanced amount, maybe like 5x on each side. Okay, so now if I was solving this, I would start by subtracting 5x on both sides, and I'm left with 1 equals 2. That's that no solution case. So really, whatever example you use For this, you just want to make sure you have balanced amount of x's on both sides and then an incorrect amount of constants on each side. So like 10x plus 5. Okay, if I make up the left-hand side, the right-hand side has to have a balanced amount of x's so that those will cancel. And I can add or subtract any number as long as it's not 5 because I don't want them both to be balanced. So here's another example. And let's say if I use 2x on both sides, maybe I'll write it in a different way. X plus x is the same as 2x, so I have that balanced amount of x's that will cancel on both sides. And then I just want to have different constants. So 3 equals 4 will again give us a no solution. Those are all different examples. Pause the video and make your own. Okay, the last question on this assignment, 4103, is talking about the domain. The domain measures your x distance or how far you travel left and right. So in that first example of this parabola facing down, we can see that you will forever travel to the left as I travel down this part of the function, and you will forever travel to the right as you travel down this part of the function. So nothing's restricting you from going left or right. For the first graph, I would say the domain is all real numbers. And that's option A. For graph number 2, we have this sideways parabola. Okay, again, domain is measuring how far we go left and right. I can see that on this function, we will go left, or on this graph, I'm sorry, we will go left forever, but we won't always go right forever. We have this boundary. Okay, this stops us from going any farther right at 3. So this domain, we use all the x's that are less than or equal to 3, and that's option C. And then graph number 3 has this vertical asymptote happening. Okay, and it also looks like it has a type of horizontal asymptote, but we're traveling left and right. That's what we're looking for domain. So I go left up until this asymptote. I don't go any farther. It's like a fence, but I do go right forever. Okay, nothing restricts me from going right, but there is this boundary at -2. So this domain is all the x's greater than -2, which was option B. Okay, take a minute to finish up your paper, take a picture and upload it to Google Classroom.